Okay, welcome to Delta Platoon Week 9, Day 2. Today we're going to continue building off of the last two lectures on SQL, and we're going to be looking in detail at joins. So joins are basically a way of, if you have multiple databases with a relationship between them, of combining certain data in the databases into like a master record that you can then query on. I think that this a picture is probably worth 1,000 words in this case. So here I'm on W3 Schools on their SQL join page. So there's four big types of joins. So you have an inner join, that's the most common. That's what I was using in the SQL queries. And it basically, you could just think this picture here. So it's a Venn diagram. Only the green area is what we're counting. You return records that have matching values in both tables. Second most common, so that's an inner join. And then there's three types of outer joins. One of them is pretty common, and that's the left join. And that takes all records from the left table and the matched records from the right table. And a right join, which returns all records from the right table and the matched records from the left table. So it looks like this, and then a full outer join, and that returns all records when there is a match in either the left or the right table. Far and away, the most common join you're going to see is the inner join, and that's the default. Like if you just use the join keyword between the two tables, you're going to get an inner join. Right join is typically used when you have like when you're querying multiple queries in complex kind of things. Left join you'll see sporadically, and then a full outer join pretty rare. So right joins and full joins, I don't even believe they're supported in SQLite. They are in Postgres, but that tells you like, you know, the amount of times they get used in real practice. But basically you need joins if you're going to do queries on multiple tables. So let me just adjust my, okay. So building on the fundamentals of select and where clauses and update and alter and the schema design that we did, those are all fundamental to what we're going to be doing here. So for this lecture, I have the CIA World Factbook. I have a database that has some of that data in it. So that's basically a product that the CIA puts out with information about countries all over the world. So let's say we want to look at a country, something S, we'll just say Samoa. Got photos of Samoa, you got their flag, country maps, geography, areas. So it captures a small portion of this data in a database. So let's look at this. And so I have a database called Factbook, which is the downloaded database that I have. Let's look at the design. So we have two tables. We have a cities table and we have facts table. So cities contains some data about cities around the world. Let's only grab like 20 records though. So I'm going to select some rows from cities, but I only want 20 of them because there's a lot of entries in the table. So you can tell they have the primary key is an ID. It's got the name of the city. It's got the population. It's got a Boolean true or false for if it's the capital of the country. And this facts ID is the country that the city is in. So if we select star from facts, limit 20. So here's what we got. We have primary key, which is this facts ID, since we're in the facts table, the country code, the country name, the area, the land area, the water area, the population, population growth, birth rate, death rate, migration rate, all sorts of facts about the city, right? So this is the data that we're working with as we start to look at joins. And then you can see, so I'm working off, I'll post this in the chat. The lecture is based on this SQL joins tutorial. I'll post this later if you want to look at it, but you can see the structure of the databases. So we have the facts, which is, you can think of the countries. It's got a foreign key relationship with cities, represented by this line. So it's a one to many. So one country can have many cities. And then the foreign key is this facts ID. Okay, so let's do a query. So let's say we just want just a simple join. We want 5 cities and the data from the countries that they're in. So it's going to look really similar to what we were looking at earlier. So we want select star from facts. We want to join that. So I could say inner join, or I could say join for Postgres. If I leave off the inner, it's just assumed to be a join. So we'll just make that join cities on cities dot facts ID equals cities facts dot ID ID, and let's just grab the first 10. So, and then let's just take a look at what this spits out. So what we're doing is an inner join between cities and the facts table, where the relationship is the primary key in the facts table and the foreign key in the cities table. And this gives us a lot of information. So basically, you could see we have all of the information on the country from the facts table. And then and then all of the information from the city in the cities table. And you can see this facts ID matches the ID of the country. And so we know that Oranjestad is in Aruba, and they get all the information on Aruba. St. John's is in Antigua and Barbuda. Am I saying that right? Someone help me out here. I'm not doing well this evening. Abu Dhabi, Dubai, Sharjah, all in the United Arab Emirates, Kabul in Afghanistan. So this is what the inner join looks like if we populate it with all the data. It takes the rows that have relations between the two tables and gives us all the data from them. Okay, so that is an inner join. So just looking at that again, the inner join, which is represented by a join in Postgres, this tells it that we want to join, the query that we're making using cities.factsid, so this foreign key equal to this primary key. And then we want all of the data from both the tables is what the star tells us. And then the limit 10 tells us just give us 10 records, because if we left the limit 10 off, it would give us a lot of data. See, we could just keep scrolling and scrolling. It's going to go through every city in the cities table. So the limit 10 is just for convenience. You got to be careful with select star from a database, especially if it's got like millions of entries, because that's going to be a hefty query. It's going to take a lot of CPU time to go through that. So just as a refresher, this select star from facts doesn't just give you all the columns from facts. Because we have the join, it's going to give you all the columns from both facts and cities based on those two keys being equal. So what does this look like in practice? So I think this is a pretty good visual representation. So if these are our tables, so we've joined them together. So basically think we've linked them together based on fax.id and city.faxid. So because we're doing an inner join, if there's a country that doesn't have a corresponding city in the cities table, then it doesn't get populated in the table. So inner join includes rows from cities where cities.faxid matches a fax.id from fax. It does not include rows from the cities tables that have a cities.faxid that doesn't match any fax.id from fax, and rows from the fax table that have a fax ID that doesn't match any cities.faxid. So it doesn't give us anything where the primary key of A, so if we think of this A as the fax table and this B as the cities table, if the primary key here doesn't match anything here, then it's excluded from this inner join in this lovely Venn diagram. So now let's look at some aliases. So let's say we want to oh, sorry. That's not what I want to do. So if I want to use aliases to represent, so I'm writing facts and cities a lot, so I can say select star from facts as F. So this F tells it every time I refer to facts in the rest of this query, it can be represented by an F. And then I want to do a join cities as C. The same thing with the as C. This is basically setting aliases or variables. So then I could say on C dot fax underscore ID equals fax. Sorry, F dot ID. So this should be functionally equivalent to, and let's just say limit. So this is the same query that we wrote here, except now we've made aliases for facts and cities, so we don't have to rewrite them here for convenience, which happens a lot, especially if you're rewriting table names or table and column names multiple times in a query, that you're going to want to use an alias. So this is the same thing with aliases used for the table names, except that there's select is singular. So you can see it gives us the same results. And you can even leave off the as, so the as is optional. The Postgres is smart enough to figure it out, I think, or maybe this is an SQL-like thing. We'll see if this works. Yep. So you can leave off the as. But I think my philosophy is always, code, including SQL, is written to be read. So to me, the as makes it more readable than leaving the as off, but that's just personal preferences. So let's say we want to do an inner join, but this time we only want the country name from the facts table. So we can do that by just defining, so we want all the information about the city. So we can alias the table name here. And then we could just say from F dot name, or sorry, F dot country name, right? It's just name, F dot name. And then we'll say, did that to myself. So now we see we've taken this and from the country table, we've only taken the name of the country, but otherwise they're identical. So we can use the aliases for the tables with wildcards if we want to select every from that table, or with column names if we only want portions of those tables. And let's say we just want the name of the city and the name of the country. That's going to look remarkably similar. So instead of wildcard to select the entire row, we just do a C dot name. So if I only want capital cities for countries, how would I select only those? Just as a reminder, this is what our cities table looks like. So if I only want capital cities and country names, how do I modify this query to get those?
Wouldn't you just put where capital equals T, string T, right? So capital is the column. Is capital the column name? I think it's capital, right?
Yeah, capital is the
Yeah.
column name. Yeah. Just to be specific, I'm not sure that the C dot capital is strictly necessary. They're necessary here because both of the tables have a column name, name, but I don't think we need the C dot capital. So let's try this. Yep. So we get only the capitals of these countries. And I think if we leave off, because there's no capital column, it'll give us the same result. So that's something to notice, is that because the column names are duplicated in two different tables, you have to reference them by the table name dot the column name in order to get what you want. Okay. So now let's look at some left joins. So as a okay, so if we want to know how many distinct country names there are in the facts table, we're going to do that by doing select count, and then we use the distinct function so we don't count any duplicates from facts. We see that there's 261 of those, and if we want to know the distinct number of cities, oh, sorry, the distinct number of countries represented in the cities table. So this tells us there's 261 countries, but then there's only 210 of those countries that have cities in the countries table. So if we're to do a left join, there's going to be some rows. There are countries in the facts table that don't have corresponding cities in the cities tables, which means, this is not an exhaustive list of cities. So we want to figure out what data is missing, basically, like which cities don't have, or sorry, which countries don't have corresponding cities in the cities table. So we can do that with a left join. Oh, sorry, I missed important. Then we want where cities dot name equals null is null. So this gives us all of our countries that don't have a city in the cities table. You see there's 51 of them, all relatively small countries. And we can see, I don't know why the European Union is represented as a,
For the Arctic Ocean.
or the Arctic Ocean. So maybe it's not countries. I think I've probably been saying it wrong. It's probably geographic areas. That's probably why it's facts and not countries. And then we could do a right join on them. I think it'll give us the same result. Or sorry, I don't want to do, I want to do a right join. That's probably a bad example. And then a full outer join, uncommon, but you can just do that with the syntax, full outer join. You could see that's just going to give you everything from both tables mashed up together. What questions do you have about joins? So this is a inner join. I'm going to say 95% of the time, inner join is the one you're going to use. Left join 4% of the time, and then right join and full outer join. The other probably less than 1% of the time. And as we get further along, particularly when we get into Django, we're going to start looking at object relational managers, which Django makes heavy use of. And basically what that is it's a layer between Python and raw SQL interfacing with the database. So most object relation managers will turn Python into SQL based on some configuration. So they're typically database agnostic. So you could use Postgres. The default database for Django is SQLite. Like you don't have to know when you're writing code for the object relational manager which database you're interfacing with. You just have to know the syntax for the object relational manager, and then it does the translation into SQL to interface with whatever database you're using for your backend or databases. Like you don't have to know that there's multiple databases. That's all handled in the backend. I mean, marginally slower than raw SQL, but most of your bottlenecks are going to be other places in the code. So you'll see it widely used. For instance, like, so the core technology that powers the backend for the company I work at has like 2 million lines of code, and it's got databases with, tens of millions of entries, and it's all done with an object relational manager. It's turning to the point where the bottleneck is not interfacing with the database, but the size of the database itself. So we're gonna have to break it up into shards. So the bottleneck is not the ORM because it just translates to raw SQL. So the performance is still going to be roughly on par with raw SQL. The way that you get in trouble with object relational managers is typically, edge cases that it's not designed to handle well. But for the most part, they do a pretty good job of, helping you not have to worry about what your database is and what SQL works on the database that's powering your backend. So what questions do you all have about joins? I think as long as you understand how an inner join works and what it does, that's going to solve 95% of your problems.
I had a question. I don't know if it's a SQL join question or if it's something that would be handled by the ORM or whatever we do for our front end interface. But let's say we have two tables that are being joined, like a customers and then their demographics. And we want to show all of that information to our users on the interface, even if they don't have information. Is that where you would use like a full outer join, or would you use some other method to show?
That's when you would probably use a left join because that's not going to care if they don't. So if you have a customer with no demographics, right, you want all the customers that in that hypothetical, and then if they have demographics, show their demographics. So in that case, a left join's going to work because that's just going to take all of your customers, and if they have demographics, it'll include it. Because
But like if they wanted to see that, oh, this customer, or I guess if both sides were missing data. I don't know if that makes sense.
so like if you had demographics that weren't associated with a customer.
Yeah, that too.
Yeah, so that would probably be like if both sides are missing data, that would be a full outer join, but it doesn't really, I mean, logically, it makes sense that if you're only going to have demographic data for customers, right? Or past customers, because they're putting it in when they fill out that optional customer data. So a left join is probably going to get you the data that you're looking for. But you're right, if both sides, both tables or multiple tables are missing data is when you're going to want to use a full outer join if you just want all the data combined together. Okay, so let's look at the challenge for this evening. Give me a sec to pull it up.
Sean, can I ask a question?
Yeah, go ahead.
Like for the left join, right? How do you specify that? Like this is the table that you will use for the left.
So it's going to be the first table.
So it's always the first. Okay, if it's a right join, then the first table will be the right. Okay,
So
got it.
yeah. Let me see if I can find a good example of the syntax. Trying to find a generic example of the syntax to call up.
Hi, sorry, I missed the question, Sean. I got my
So
daughter on my lap here.
The question is if you're left join versus right join, how do you specify, so when you're looking at this, how do you specify what's your left and what's your right? And it's done by, so let's say we have, where's this? Tell us what the This isn't a very good example. I was trying to find a good example with the syntax and pictures to show. What the syntax is. Okay, so I think here's what we're looking for. So here's the pictorial representation of a left join. So if select star from table, so table one is what's our left in this case, and then left outer, with the outer is optional, join table two. So that's how you specify. So select star from table one, left join. So left join, you're left joining table two. And then it should be, is there an example of a right join? Yeah, and that's the same. So whatever your left or right is going to be your from clause, and then your right join is going to be whatever the other side is in the syntax. Does that answer your question?
Yes, thank you.
Okay, so tonight the challenge is SQL Zoo, which is linked on the curriculum page. Basically, it's some interactive SQL tutorials where it walks you through some of the basics of SQL. Some of this is going to be a refresher, and some of this, once you get down to joins and whatnot. So if you feel like, this stuff is too much of a refresher, you can skip down to join operations. But basically, walk through this, and then you can, I don't think, you don't need to do this part on MySQL or this part on DDL student records. So 0 through 10, I would say, and there's some reference down here if you need to look anything up. So what questions do you all have about the challenge for tonight or the lecture?
Yes, how can we get that fact book database?
I'll post it. I will push it up to Delta Platoon GitHub.
Okay, thank you.
Thanks. I was gonna ask the same thing.
Yeah, to play around with.
Same
Yeah,
here.
I'll push it up, and then I'll post the link to the tutorial that I was talking from for the lecture.
I have a good question. I probably know the answer to, but I just want to make sure. The foreign keys, are they always named so clearly that they're associated with the ID from the other table? Like if it's a class.
They should be. That's the convention. I mean, theoretically, you could name them whatever you want, but the syntax is table name underscore primary key name for a foreign key.
Okay.